Hello everyone. Welcome to the Autodesk University talk, Forge, Breaking Out of the Browser. My name is Peter Braz. I'm a Forge developer advocate. And in this talk, I'm happy to share with you some of the tips and tricks you can follow when you're interested in bringing your Forge designs into special environments out of the web browser. While the Autodesk Forge platform is mainly focused on visualizing your designs in a web browser using the Forge Viewer component, there are many use cases where our customers need to be able to take their designs elsewhere. For example, some of our customers want to be able to build custom augmented reality or virtual reality experiences around their Forge designs. Other customers may need to be able to take their Forge models into native mobile applications. Other customers may want to stay in the web environment, but they need to be able to combine their Forge designs with GIS data or point cloud data using other web rendering technologies. There is also a special class of use cases where some of our customers need to be able to post-process the geometry extracted from your designs by the model derivative service to allow for things like spatial or metadata filtering and supporting more efficient transfer of the geometry into special low-performance devices, for example. While the Forge platform does not offer an official solution for these use cases, there are a couple of options that we would encourage you to check out. There are 3 of them, and we will cover all of these options in this talk. First of all, you can consider using the OBJ file format that can be extracted by the model derivative service. OBJ is a simple text-based open file format representing 3D geometry and basic materials. It is very easy to parse. There are many existing tools to load or save or process this format. Keep in mind, however, that since it's text-based, OBJ is quite verbose and may not scale well for large or complex designs. Also, the format is lossy in a sense that you may lose information such as material definition or metadata when converting your Forge designs into OBJ. On the Forge side, you can retrieve OBJs by basically providing OBJ output type when triggering the model derivative job. While doing so, you will also need to provide 2 additional pieces of information: the GUID of a specific viewable that was extracted for your design by the model derivative service, and a list of object IDs specifying the objects from this viewable that you actually want to include in the output. If you're interested in this approach, we provide a link to a step-by-step tutorial available on our Forge portal. And we also recommend that you try our OSS Manager application where this feature is enabled. OSS Manager is one of the demo Forge applications built by our team that allows you to access Forge services and content with your own Forge application credentials. You can see here I'm taking the client ID and client secret of one of my own Forge applications, logging in, and using it to navigate through my content in Forge. I select a bike frame model from Fusion 360, select one of the components in the viewer, and export it as OBJ. And there you go. This is the first simple way of extracting geometry from the model derivative service in a format that can then be consumed in other third-party applications. Another option is to use a service called AR/VR Toolkit. AR/VR Toolkit is a side project of one of our colleagues started a couple of years ago. It's a combination of a server-side API and a Unity plugin. The service builds on top of Forge, meaning that it takes the internal file format for 3D geometry extracted from your designs by the model-derived service, and it post-processes this geometry information in a granular format that can then be used to efficiently stream the information to a Unity application running on all sorts of devices, for example, on VR goggles or AR/VR devices such as HoloLens. The AR/VR Toolkit server also uses the same authentication system as Forge. So when communicating with the AR/VR Toolkit server side, you can use the same access token you would use if you were communicating with Forge platform itself. Now let's take a look at the AR/VR Toolkit in action. Before we can start loading any information into Unity, we need to follow three main steps. First of all, we need to specify something called AR/VR Toolkit scene. AR/VR Toolkit scene basically represents all the information we want to extract from a specific model in Forge. We provide the URN of this model in the model-derived service, and we can optionally specify additional configurations such as Bin360 project ID or a list of objects we actually want to export from this model in Forge. Once the scene is defined, we start an AR/VR Toolkit processing job. And here we once again specify the URN of a model in the model derivative service and the name of the scene that we have just created. We can leverage the same access token. Now we specify the name of the scene and we submit the job. So now the AR/VR Toolkit is processing our new scene to make it available in Unity. The third step is checking the status of this processing. We can once again reuse the access token and the model URN for which the scene was defined. And we can start checking the status of the processing by retrieving a manifest from the AR/VR Toolkit server and searching for AR-Kit output. You can see that the processing of our scene called MyScene1 is now at 49%. Let's skip ahead a little bit. All right, now you can see our scene has finished processing. We can go to Unity and install the AR/VR Toolkit Unity package that can be downloaded from the Forge Toolkit website. The package includes a prefab called Forge Loader, which is basically a game object that allows you to specify some of the input parameters and it loads your model during runtime. You can see we require model URN, access token, and a scene ID. Let's start with the model URN. This is the URN of our design in Forge that we want to extract, to load into Unity. We take the same access token we used when processing the AR/VR Toolkit scene, and we specify the scene name itself, MyScene1. Now let's just activate the Forge Loader object and run our Unity app. And there you go. Our Forge model is now being loaded into Unity. The third option is leveraging another file format called GLTF. GLTF is an open format for 3D data exchange on the web, created and maintained by the Chronos Consortium, the same group that's responsible for maintaining open standards such as WebGL, OpenGL, or Vulkan. The GLTF file format has been around for a couple of years, and during the time it has seen a strong adoption, and it grew its ecosystem of tools, or loaders, exporters, validators, processors, and the ecosystem of GLTF and the community is very vivid. On the Forge side, there is a plan to offer GLTF as another native output in the model derivative service. But until before that is available, there is another option we recommend that you check out. We provide a library called Forge Convert Utils. This project, available on GitHub, is a Node.js library and also a command line tool that can be used to translate the internal file format extracted from your designs by the Forge model derivative service into this GLTF format. Just like the AR/VR toolkit, the Forge Convert Utils library also builds on top of Forge, which means that before you can use it, you will want to process your designs in Forge with the model derivative service. And it also uses the same authentication. So again, you can use the same access token that you would use if you were communicating with the standard Forge services. Now let's take a look at the Forge Convert Utils library in action. We will use the Forge extension in Visual Studio Code to obtain some of the inputs. We start by installing the Forge Convert utility globally using npm. Next, we use the Forge extension in Visual Studio Code to generate an access token for Forge, and we will define it as an environment variable called Forge access token in our terminal. Next, we take the URN of one of our models in Forge that we're going to convert, and we use it as a parameter to a command line tool called forge-convert. Now you can see the utility is extracting information from the model derivative service and storing the output GLTF file locally. Here we can navigate the GLTF manifest itself, and we use another open source extension for Visual Studio Code that allows us to navigate the GLTF content and even preview the 3D model directly inside Visual Studio Code using different rendering engines such as Babylon, 3JS, or Filament. Next, let's try using the GLTF conversion functionality, which is also built into the Forge Visual Studio Code extension itself. We can right-click the object in the sidebar and say download as GLTF. And the Visual Studio Code extension will use the same Node.js library to download GLTF to a local folder. Now let's check out the bike frame S3D folder, one of the viewables, and the GLTF output again. And there we are. The GLTF file exported from a Fusion 360 file in Forge. And that is it for our 3 options of bringing Forge designs out of the browser into other platforms and environments. If you have any questions, bugs you would like to report, or feature requests for one of the mentioned technologies, please let us know. You can contact us on Twitter or via email. Thank you very much for your attention.